You will be responsible for identifying two different functional groups that contain nitrogen. The first functional group that we're going to discuss is a functional group known as an amine. An amine occurs when we have a nitrogen atom that has a single bond to at least one carbon atom, where the other bonds are going to be to hydrogen. Amines are classified by how many nitrogen carbon bonds there are. If nitrogen is directly bonded to one carbon containing group, that's known as a primary amine, and the other bonds are hydrogen. A secondary amine has two nitrogen carbon bonds, the other bond is to a hydrogen, and a tertiary amine has three nitrogen carbon bonds. And the carbon group that is bonded to the nitrogen can be the same or different in the secondary and tertiary amines. Now you may recall the structure of ammonia, nitrogen with three hydrogens. The nitrogen in ammonia has four electron pairs around it, a lone pair, and three bonding pairs. And that's a very similar structure to amines. Amines have three single bonds, so six total electrons, and then a lone pair that is generally not expressly written, but it does impact the overall geometry. So the bond angles in amines are going to be slightly less than 109.5 because that lone pair has extra repulsion power compared to the repelling power in bonding electrons. Here is a ball and stick and a three-dimensional structure of methylamine, a primary amine. We see that one nitrogen carbon bond and the two hydrogen atoms. Here's an example of a tertiary amine, trimethylamine, and here we see in the ball and stick model three nitrogen carbon bonds, and these bond angles are going to be slightly less than 109.5. A distinctive characteristic of amines is their foul odors. At the bottom of the slide, we see the structure of putrescine and cadaverine, two amines that are often given off when rotting flesh, such as muscle that contains a lot of protein, give off. And if you've ever smelled rotting fish, then you know what an amine smells like.